Welcome to our unit on energy. And the first topic in our unit on energy is oil, one of the most important energy sources on the planet. Now, when it comes to oil, we don't really use it to produce electricity. However, we do use it tremendously in the transportation sector and for home heating oil. So oil is obviously a very, very in-demand resource. And there are questions about how long this resource will last on planet Earth. So should we be looking for alternatives? Hopefully you'll find a newfound respect for this energy resource. All right, so what is oil and how is it created? Oil is created over millions of years through the deposit of dead sea organisms that deposit on the bottom of the ocean. All right, so we're talking about dead ocean critters that deposit at the bottom of the ocean in horizontal layers. All right, and then over geologic time, those layers are buried and are succumbed to geologic heat, pressure, and time. Okay, so inside those layers, those organisms, the bodies of the dead organisms, are crushed, and the hydrocarbons are basically squeezed out and make these deposits of what we call oil and natural gas. All right, so real far down deep in geologic deposits, you'll see layers of hydrocarbon. All right, typically they form in layers of what's called shale, and we can then try and find those deposits of this hydrocarbon and extract it and use it for energy. All right, geologically, it's very difficult to locate natural gas and oil deposits, and if you notice, natural gas is usually associated with oil. The two form together. All right, and what happens is ancient seabeds form horizontally, but then over geologic time, there's plate tectonics and collisions and so forth, which bend and fold rock. And what happens is these domes will form. All right, and inside those domes, the lighter oil and gas will basically float to the top of these domes and become trapped by layers of impermeable rock. All right, the natural gas, which is a little bit lighter and more refined, will float to the top. All right, and then the oil will be found just below the natural gas deposit. So modern day geologists need to go on the surface of the earth and basically dig test wells to try and locate those resources, the oil and the natural gas that might be thousands of feet underground. Lots and lots of money has gone into research to not only locate but also to extract these oil and gas deposit. Drilling procedures, we still use ones today that were developed by Howard Hughes, and if you look up Howard Hughes, he's a very interesting story. But these drill bits are diamond tipped. They're made of things like tungsten carbide. We've now developed technologies where we can drill horizontally into these deposits and extract more oil and more gas than before. So technology is always changing and improving, but it's still very difficult and costly to locate these oil and gas deposits, especially if they're offshore. All right, we can also do it offshore. So really, companies aren't going to undertake these very costly procedures if they're not pretty sure that they're going to find oil and gas. So there's a lot of economics behind locating and then also extracting oil and natural gas. Current techniques can only get about 50% of the resource extracted. All right, we can only recover about 50% of the resource, and that's through primary recovery. So primary recovery is drilling a well down, all right, and the first stuff that comes out is the less dense, more refined product. All right, and you pump it out using derricks or pumps. Okay, so let's call that primary recovery. Okay, but then there's also secondary recovery. In secondary recovery, we can use carbon dioxide. So what you're going to do is you're going to pump carbon dioxide, which is dissolvable in oil, and it'll basically make the remaining droplets larger and bulkier and therefore easier to pump out. So we're going to use CO2, which is dissolvable in oil, and then can extract maybe another 25% of the deposit. So we're not 100% effective here, but through primary and secondary recovery, we can get almost up to 75% of the deposit. So maybe in the future, there will be better technology and we can get more out of it. But at this point, it's not economically wise to do so. All right, so primary and secondary recovery is how we get the oil out. When it comes out of the ground, it's not ready to go and put in our engines and in our home heating tanks. What comes out of the ground is called crude oil. And crude oil comes in two different types, heavy crude and light crude. All right, crude oil is made up of different materials that need to be separated. It's very thick and gooey. It contains tar. It stains. This is not the typical oil in society. It needs to be refined. So when we pump or extract oil out of the ground, where it's extracted, it usually needs to be transported to our refineries. And we'll talk about how we transport it in a second. But you're looking at heavy crude oil here. It's very thick and gooey. It's of a lesser quality. There's more tar involved in heavy crude than its brother, the light crude. All right, this is the good stuff. We use this more for our gas, diesel, and other products that we use. So light crude is the better of the two types of crude oil. All right, and here's a picture of how we get it out of the ground. You see the oil derricks basically pumping the resource out of the ground. Now, when it comes to transportation, we use two different methods, and the first one is pipelines. Again, some of these oil deposits are in very remote locations, and the refineries are very, very far away, sometimes thousands of miles. So pipelines can easily transport crude oil to the refineries where it can be refined into the products that we use. All right, the other way that we transport oil is through ship. All right, these gigantic tankers. All right, these are the largest super tankers in the world. If you look here at this one, this is one of the bigger ones. There's literally a 5-story building on this tanker, which houses the crew's quarters. It's where they eat and sleep. There's thousands of these ships out every day. All right, so this is how oil is transported in pipelines and in super tankers. I think I have a picture of the Knock Nevis. I do. This is one of the largest super tankers in the world. All right, so we need to get that crude oil to the oil refineries. This is where the process of separation occurs. This is where we're going to create gas for our cars and home heating oil and diesel products and so forth. So that crude oil needs to be refined, and here is where we're going to do it. All right, the process is very complicated, but let's simplify it here. There's a lot of environmental consequences of all these procedures in the life cycle of oil, from extraction to transportation to refining through use. All right, but let's simplify this process very quickly. So what we're going to do is we're going to take the crude oil that we extracted from the ground and transport it to the refinery. That crude oil is going to be boiled in a boiler, all right, and turned to gas. All right, and then that gas is going to move through a pipe into the distillation column, sometimes called the cracking tower. All right, so the oil, which is now in a gaseous state, goes through the distillation tower, and as it rises, it will cool and condense back into a liquid. And each product cools at a different temperature. So if you notice here, lubricating oil right here will condense back out at around 300 degrees Celsius. So that'll be one of the first oil products to condense out. As the gas continues to rise here, our diesel fuel will condense out at a different temperature, around 200 degrees Celsius. All right, our kerosene at a different temperature, our gasoline at around 120 degrees Celsius. And then the lighter oil products will condense out last. Okay, so because each product cools at a different temperature, using the distillation column method, we can now condense the different products out separately. And at the top is the better refined stuff, and at the bottom is the lesser refined stuff. So by simply boiling it and cooling it up the distillation column, we can separate and collect the different products out of a barrel of crude oil. All right, and within every barrel of crude oil, about 47% of a barrel is gasoline. And I should tell you that each barrel, when you hear a barrel of crude oil, what we're talking about is about 42 gallons of product, all right, of crude oil. So each barrel is 42 gallons. And you'll hear and read how many millions of barrels are used per day, things like that. So when you hear a barrel, we're talking about 42 gallons of product. All right, and in each barrel, about half of it is gasoline. All right, about 23% of it will become diesel fuel and heating oil. All right, so that's 75% of a barrel of oil right there, gasoline and diesel and heating oil. All right, and then you got your other products, your jet fuel, 3% is asphalt. So most of a barrel of oil goes to gasoline, diesel fuel, and heating oil. Again, transportation and domestic use, heat. All right, we don't really use oil for electricity. Okay, and here you go. There's a little pie chart to prove my point. All right, oil is used for so much more things other than transportation and home heating purposes. All right, think about the consequences of using oil in our society. We tend to forget how much of our society is tied up in oil. All the products that you see here are made from oil, from makeup to crayons to epoxy to different dyes. Any product that is made from plastic is made from oil. So where are some of the places we get our oil? The United States has thousands of oil wells that are all pulling out oil. And some of the largest ones are in the northern part of Alaska, all right, in a place called Crude Bay. All right, this is where we get a large majority of our domestic oil. But there's a problem. How do you get this oil to the lower 48 states where we use most of it? All right, well, there's two ways. You either use a pipeline or you ship it by boat, right? The normal transportation methods for oil. Now, there's an issue here with northern Alaska. The Beaufort Bay freezes solid every fall, winter, and spring. So any tankers that are up here need to watch the calendar and make sure that you're working around months where it's not frozen, because tanker ships that are coming to and from Crude Bay need to go through Beaufort Bay, which freezes solid. So you can only use Beaufort Bay at certain times of the year. All right, so what was built was a pipeline from northern Alaska all the way to a city called Valdez. All right, and this is where the tankers are going to come to and from and pick up the oil from Valdez. But that pipeline, which spans the entire state of Alaska, all right, is called the Alaskan Pipeline. All right, you're talking about 700 miles of Alaskan pipeline. All right, that would stretch from Pennsylvania to Florida if you put it on the East Coast. All right, it's above ground so that you can check for leaks. If there's any problems, you can monitor it. All right, but there's environmental issues with doing that, and we'll talk about those, and maybe you can even guess some of those while we're talking about this. But the Alaskan Pipeline is probably the main way to get crude oil from where it's drilled in northern Alaska down to Valdez, where we can then ship it out to the oil refineries in the lower 48 states. All right, so here's a picture of the pipeline. You can see it's above ground. Animals can go under it and pass right through. All right, and you can also check and monitor if there's any leaks. If it's underground, you can think about how difficult it would be to be able to detect a leak, all right, until it's basically too late. Let's look at the location at the end of the Great Alaskan Pipeline, Valdez, all right, a city in Alaska. All right, at the end of the pipeline is the city of Valdez, and this is where all the big tankers are going to come into Prince William Sound, pick up the crude oil, and then ship it to the refineries in the lower 48 states. So now what we're going to be looking at here is a case study in an oil spill called the Exxon Valdez oil spill. All right, you can imagine that when we're dealing with oil, spills are an environmental issue. So this one occurred in 1989, and what happened was there was a super tanker that came in here. You could think of Valdez as being in a very dangerous place. It's very far back, protected from the ocean, and Prince William Sound isn't very easy to navigate. You have these super tankers coming in here, and they have to navigate just like a road. You have to stay to the right, all right? And you have to navigate these little islands here, come into Valdez, pick up the product, and then leave, again, staying to the right. Okay, so what happened in 1989, one of these super tankers, the Exxon Valdez, came into Valdez, picked up 52 million gallons of oil, and because of what they claimed as a navigation problem, it basically went across the road over the left-hand lane and smashed into Bly Reef, which is a series of boulders that are underwater. All right, it tore open the side, and over a 2-week period, there was 11 million gallons of oil spilled in Prince William Sound, which is a very delicate, pristine wildlife area. Back then, cleanup technologies and their ability to handle the spill was not very good, so the oil spread. It covered over 1,000 miles of beaches. It killed over 1,000 mammals and over 10,000 birds and other animals. And even after the cleanup, they only were able to retrieve about 2.6 million gallons of oil of the 11 million gallons that were spilled. So even after it was cleaned up, the rest remained in the environment and is still there today. You don't actually see it, but if you dig down in the sand a little bit on some of these beaches, you'll find it. And scientists estimate that it'll be there for the next 100 years or more. So the Exxon Valdez oil spill is a nice case study to look at when we're looking at what can happen in the case of an oil spill of millions of gallons into a pristine wildlife area.